Well, hello. How's everybody today? Good morning, good evening, good afternoon, wherever this video finds you. We're going to be working on chapter or module 4, dictionaries and serializing objects. We will brush a little bit on sets, but we're going to concentrate on dictionaries and serializing objects. So, to begin with, what is a dictionary? And a dictionary, I'm going to use a term here when I'm also discussing what a dictionary is, and it's called a hash table. Because basically, what a dictionary is implemented as what is called hash tables in other programming languages. And a hash table is essentially a way of storing information in an array or a list, and what the place that you store that information in the list is based on a key you give to it, and that's what makes it the hash table. Mostly when you're working with a dictionary, you're always going to have a key that represents where in the list that value actually is located for the dictionary. And just like all objects, it's got some properties such as the key is something that can't be changed. It's immutable. And one of the terms they use here in Python is mapping the key to a specific value. And what does that look like? And we're going to talk about that here shortly. But to begin with, let's just create we're going to create a dictionary, and then we're going to discuss some of the particulars of it and play around with it. And then, of course, we'll move on to playing around with pickling. We're going to actually, because when you use the pickle library, you can save information as binary. And one nice thing about dictionaries, a dictionary object is able to be pickled. So when you build lists of information based on a key value pair, you can chunk it to disk real quick and easy, and then load it from disk fairly easy. So the key value pair functionality really helps to solve quite a few problems that you would find yourself having to solve in programming. And you'll see that, when you get to your assignments. Try to think, hey, how can I solve this problem with a dictionary? All the way to, you can even use a dictionary. I call them frequency arrays. A dictionary can track the frequency of a specific key value or key or value, depending on how you use it. So a dictionary, even though the key is immutable, once you set up the key within the dictionary itself, they are considered mutable objects. That means that you can add to them, remove from a dictionary. You can change values in a dictionary. You just can't change keys. Well, you really don't want to anyways, so that's not something we really need to go into. So if a key does exist in the dictionary, then you can use that same key to change the value that's located at that key location. So I think before we get too far into this, what I'd like to do is we're going to get on the whiteboard. We're going to get in Visual Studio Code and play around with some of this stuff, and that way we can get our hands occupied. And we'll be coming back to this whiteboard here shortly, but I'm going to pop up, we did chapter 6, golf scores. So here's usually what I do when I go build something new. I'm just going to copy the folder, the whole folder of what I made, and I'm going to just paste it in here. And I'm going to rename this because I'm going to use this project for the demonstration for this chapter. So I'm going to go ahead and just I'm going to call it Module 4. The heck with it. And golf scores is kind of what we were working on. I'm going to rename that guy to Mod 4, and then of course I'll probably give it a better name later. That's just so I don't have to start off with redoing the main and all that stuff, which drives me insane. Okay, let's go ahead and get this zoomed in for you. And I'm going to begin with a dictionary. And we will then come right back. I'm going to actually take a little time off to the side, get it zoomed in, and get a dictionary prepared for you. So I'll be back shortly. See you soon. Okay, I got everything zoomed in and ready to go. We have an example of creating a dictionary down here. However, I've got a better example that we can use from W3 Schools. W3 Schools, it's pretty good. It's got some good references. I use it quite often just to grab code snippets. This is an example of creating a dictionary. I would call this a hard-coded dictionary, meaning that you're both instantiating, creating the dictionary, and assigning it static value, or not static, but values at the same time. So what I'm going to do is I'm going to go down here to try it yourself, and this way when I copy paste, I should get very little indenting errors. Let's go ahead and take it to our development environment. And of course, we're going to have indenting errors, but we shouldn't have as many. Okay, now let's just get this running, and then we're going to play around with it, and then of course discuss it on the whiteboard. All right, we should be able to print, and you can see here that we're outputting the dictionary. If we run this in the debugger, when we get to the print, we can see that actually getting into the debug window. There we go. So when I do a step over here, it should pop up in my locals. There it is, and then we can see that it's filled up. So a lot of times, try not to use print to do your debugging. Get in here and actually look at your locals. It's easy to do, and it shows you a bigger picture of what's going on than using the print method for your debugging. Okay, so what is a dictionary? Well, we discussed how it's like I use the term hash table. So the way it's implemented, and if we think about this key value pair, let's just go ahead and say that let's get rid of these guys and be very simplistic here. This guy right here, what we're doing is this open brace and this closing brace is what signifies it as a dictionary. So as soon as Python sees that you're assigning something with that open brace and that closing brace, that's what's creating the dictionary part of it. I got to get rid of this little trailing comma here. So what ends up happening is behind the scenes, this is a list that's being created, an array. And what happens is the key is the location in the list where the value is stored. So what does that actually look like? So if we bring up the whiteboard, let's say that we have, and looks like I got my pen here that I've got to Oh, there we go. Okay. So we have the key is brand. So that is where we are. That is what we are going to use as our key. And at that location, we're going to install, or we're going to put Ford. So essentially, in our list, we have elements 0, 1, 2, 3, 4, 5. And what we can do is we can decide where Ford is stored in the list based on its key. So mathematically, what happens behind the scenes is a routine will add up, and it could use the ASCII values. It could use the ASCII values of each of these characters. But let's say that B equals 2, R equals, and I'm just going to be so simplistic, even though R is not going to be equal to 3. 3, A is equal to 4, N is equal to 5, and D is equal to 6. Okay, those aren't the actual values. I'm just throwing these in there. So what will then happen is to determine where Ford is going to be placed in the array, these characters will be counted up, and some mathematical magic will happen to determine what index does Ford go to. So to give you an example, let's say 6 plus 5, 11, plus 4, 15, 18, 19, 20. So let's say that our key adds up to 20, and then we look at it and we see, oh, our list is only 5 long. So then what you can do is you can say 20 modulus, you can do another thing that's, what's the remainder of 20 divided by 5? And 20 divided by 5 is 4 with a remainder of 0. So then brand will go right here, because 0 is the answer to our mathematical mumbo jumbo to determine where Ford will go here, because that's what the key tells it where it's located is at. And the reason why I did modulus 5 here is because our list is only 5 long. That causes problems when we have keys that will evaluate to the same numbers or indexes in the list. That's all handled behind the scenes, and we don't need to concern ourselves with it. That's all computer science stuff that you get in the straight science portion of programming. And, we don't care. This is Python. We just want to use the darn thing. So let's say that we have another key that has an S here. And let's say that this number, now that we add that S there, this number is 22. So the brands key adds up to 22. We do the modulus of 5. We do 22 modulus 5. Well, that's 4 with a remainder of 2. So brands, we say, goes into location 2. So at brands, let's say that we want, I'm not going to spell it all out. Let's say that we want the value toy for Toyota to go in the brands key. Well, brands will add up all the way to the value, doing the mathematical mumbo jumbo, brands comes out to be stored in location 2. So then we put toy here in location 2. And that's how the key value pair works. It's essentially a higher working list. It's a list that works with rules. And so your key is very important, and there's specific rules that go with that key, because if you have the same key, then it's always going to evaluate. Let's say that we want toy to go to brands with brand without the S. Let's say we want toy to go to brand. And so that then means that brand will evaluate to 0 again, and toy will overwrite the value that's in there. And now Ford is gone and toy is in there instead. So that the rules of the key are very, when you dive deep into dictionaries and you get a better understanding of working with that key, it's very important because that key is essentially where in the list does that value go. And of course, it's not way more complicated than what I've shown you. It's just a little bit more sophisticated. Because we don't want some other value, so some other key like model. We don't want model key. Like if we have a model that it's a Tundra, we don't want the model key to evaluate the same thing as the brand key does. And that's what we call collision. So there's some sophistication behind the scenes to stop collisions or handle the collisions. And therefore you can work with that key value pair easily. But here's where it gets into, well, why do we have hash tables? Why do we have dictionaries? And the reason being is when we are working with the normal list, to find something in this list, we have to start at the very beginning of the list. And let's say that we're looking for toy in the list. If we are and I'm talking about a list now, not a dictionary. If we are trying to find toy inside of this list, we would have to start and say, hey, is toy there? And let's say Ford is there. Nope, toy is not here. Then we have to look at this guy. Is toy here? Nope. Is toy here? Yep, we found it. What if toy is all the way here at the end? And what if this list is 1,000,000 items? So that means that I have to go through 1,000,000 items from start to finish and look at each one just to find this value. Well, what if the value and that was dependent on a key, or even you could use the value as a key? I've seen that done. Why not use the value as a key? That happens. So essentially what it makes is for very fast data storage and data retrieval. The only issue that you have is the rules of working with your keys, and a lot of that's handled behind the scenes, but this is what a dictionary is. It's a very fancy list or array. And other languages refer to them as hash tables. However, it's made for you guys to really work with it easily with what we call a key value pair. Okay, now that's enough on that. Now let's go ahead and play a little bit on this. What we can do is we can actually create an empty list. Now this is what I would think of as we are no longer hard coding the list. And this is the way you would determine most lists. I don't like to, hard code things, because often what a list will be based on is dynamic data that's coming to me. Like let's say I'm reading a log file from a certain service, and I put that data in a list so that I can dump it to disk using pickle fairly easily. So a lot of times when you're working with dictionaries, this is the way your dictionary is going to be created, because you're not going to want to, in most cases, the dictionary is for data that comes in where you don't really know what you're getting, and you make decisions and put the data in a dictionary to order it in some fashion based on that key value pair relationship. So how do I add then, when I create an empty dictionary, how do I add an item to it? And Python makes this super simple. we just use the name of the dictionary, and we reference the key of where we want to put that particular value. Let me see if I get the syntax, if I remember the syntax properly. I believe we will say model here is equal to, well, I don't, brand. Yeah, okay. Yeah, we were working with brand here. Brand and Ford go together. Okay, and then we can print the dictionary and view it. So let's see what actually happens in the debugger, and then we're gonna head back to the PowerPoint and kind of continue on. We'll come back to here when we work on removing items from the dictionary. Okay, there we go. Add a dictionary. There's my brand and Ford. And then you can print the dictionary. Well, how would I print just a single item on the dictionary? Well, why couldn't we just do this? If we want to just print the location that, or the value that is at a specific location, we can put in the dictionary name and use the bracket, the subscript of the key, and then what that'll print is just the value Ford. Because we're saying don't print the whole dictionary, print what is located at this key of the dictionary. Okay, and we should have our Ford down here. We do. All right, guys, I'm going to come back to you here with some more on the PowerPoint. I'll see you soon. Okay, let's finish up some discussion on, more of a discussion on Python dictionaries. And the one thing that I do want to demonstrate is how to delete something from a dictionary. We've already discussed how to add elements to dictionary. You just give the dictionary name, you inject the key, and then you give it a value. Now this is an example of how to delete something from the dictionary. So let's play with that, and then what we're going to do is we're going to use the len function, and we're going to print specific items from a dictionary using a for loop. And then we're going to get into sets. So let's go ahead and kind of bring this out a little bit more, and let's print the whole dictionary, and let's actually get this so it's not in my face. Okay, now I'm going to just be putting some different things in here. We'll say model F-150. And then what is another thing? Let's call it power, and let's say 300 horsepower or something like that. Now you also can, have that as an integral value. It doesn't have to be tied specifically to a certain data type. Your key, you want to always use a string for your key. And this is an example of multiple items they're adding to the dictionary. Okay, and we have our printout right here. And we have mixed data types in here. I'm mixing that integer in with strings inside of the dictionary. Now, to delete something, it's really simple. What we can do is we can say, okay, delete from the dictionary the value at the power key. And what we'll find is that previously we printed that power key. What we'll do is we'll find that pow will no longer be printed. And you see down here, okay, so it only prints out the brand and the model. because we deleted this item from the dictionary. Now let's go in and look at how to actually walk the list. You can do it a few different ways, but the best way, by the way, length, the len function will return how many items are in the dictionary for you. And that's one way, another way that you can use looping to parse through your list. But one of the better ways to deal with looping through items in a dictionary is working with a for loop. And this is an example of a for every key in the dictionary. Other languages would use this as a for each statement. And what it does is it will loop through every specific singular item so that you can print just the items by itself, or process your dictionary in a loop that looks at every item in the dictionary. So for, let's say the key, key in this dictionary. And what we can do is we can say print, and we can print the key, K. K will print the key. So let's start with just that. Let's just print the key of every item in the dictionary. Okay, so we see down here in my output that my print statement output the first key, which was brand. This is line 10 working. Then the next time through the loop, it printed model and then POW. So there's a lot of different ways of processing dictionaries. This is one of the easier ways to do it. Now let's say that we wanted to print just the values. So then what you would do is you would put in here this dictionary, and you would put the key K that walks through every key that's in the dictionary, so that you can output just the values based on the keys that K walks through in your for each statement here. So what K is being assigned to initially is brand. Then the next time through the loop, K is being assigned to model. Then the next time through the loop, K is being assigned to the key POW, or POW, for power, horsepower, whatever. And so we can use that K as it walks through every key in the list to output those items. And so when I run this, we can see that, hey, we output the values Ford, F-150, 300. Well, let's say that we wanted to output the key and the value. So I could say K here, comma, and I'm going to use the prints method of doing multiple items. And I'm just going to inject a space in here. I know you guys can't see it because I got that silly thing. So basically I say output K and this, the key or the value at location K in the dictionary, and then put a space in between that. And then we can see that we have an error because evidently okay. So it tried to do what we were, but here's where it died. You see it ran 2 times first. It ran 2 times, but when it got to this mixed data type 300, because I add this string to it, it didn't know that the value at this location was an integer, and it couldn't handle converting it to a string when I did this plus. And so that will cause problems, and we would have to do an if statement in here to convert this back, or to convert it and detect that it was an actual integral value, so that we didn't add the plus to it. So we can do something simple like if this dictionary of K is an integral, then make the conversion and then add the space. Or we can just say the heck with it. Let's, instead of doing the conversion, let's just print K first, then print the space, and then print the dictionary, or this. I hate that little pop-up, by the way. It's driving me nuts. At location K. Okay, even though, okay, oh my goodness, that thing is driving me nuts. Okay, so this would solve that problem fairly easily because we're no longer converting an integer and trying to concatenate it onto a space. So now this would run and work out just fine. So, you know, that's one thing you want to keep in mind. I think it, oh yeah, okay, we don't need the space at all. We can have other methods of dealing with this. Actually, you know what? I know what will work. This will work. That will do the space for me without having to do any conversions. But see, the print method always does a new line, so it doesn't really matter, and I don't want to get into the details. But there is a version that you can do that does not add a new line. So you can see that all these add a new line, and I don't want to get into Google and get sidetracked on that. So let's go ahead and move on and get back to the PowerPoint. We've deleted something from the list. We've walked through the list with a loop. And let's talk about some of the particular functions that are available to you. You can clear the whole list. You can delete the whole dictionary. And I'm using the word list interchangeably with dictionary. You know, so just remember that I mean dictionary. So we can clear the whole dictionary with this function. The items function is going to return all your keys. So you can use this in a for loop to because you can have a dictionary inside of a dictionary, guys. Yeah, you can have multiple dictionaries. So you can have a dictionary that's stored inside of a dictionary. And you can have a dictionary that's stored inside of a dictionary that's stored inside of a dictionary. So it can get pretty complicated very fast when you're working with dictionaries and items that are, all put together inside of a multi-dimensional dictionary. And I'm not going to get into the weeds on that. That can be a good enough challenge for you because we got a whole bunch of PowerPoint to go over. Now this one will give you all the keys and its associated values. So this function will return all the items in the dictionary, and you can parse and tokenize those items. This will just return all the keys. Now the pop function, what it's going to do is it's going to pop and remove an item off of the list based on its key, and it'll return the value based on on what key you send it. So when you do a pop, it's going to give you that item that's at that key location, but here's the thing. It's also going to remove it. So the pop function will remove that key value pair. So it works like the delete. And you can pop an item. So you can use this pop item, and what it does is it's not very useful because you can use it for random selection of a key value pair, essentially from the dictionary. If that's something that you want to be returned. And they use this term tuple. So basically tuple, remember, that's just a list that is unmodifiable. So basically it returns the key value pair as an array, as a list. And but it's a list that you can't change. Now if you want to get the values, just the values from the dictionary, you can get a list of values from the dictionary using the values function. So we have a lot of different functions that we can play around with for a dictionary, such as, getting all the items as a list, tuple, unmodified list. with its key and value, or all the keys as a list, or all the values as a list. The pop functions work to remove items from the list, so that you can use it like the delete, and so forth. So let's play with the pop and see how that works. I may have an issue, but we'll see if so. Let's go ahead and do this. Let's run the pop function. And what we're going to do is we're going to pop location POW. Let's go ahead and set a breakpoint and see if I'm doing the right syntax and semantics. I may need to refresh myself on W3 schools or something, but I think this is the way it works. And if we look at it, we can see, yeah, it works just fine. It removes the power POW300 key value pair. So those are functions that you can use when you're working with a dictionary. And again, here's where I would say to challenge yourself if you really want to, because dictionaries are used often for data processing in Python because of the power of that key value pair relationship. You can solve a lot of problems based on design, and the design of a dictionary makes it so that you can use a dictionary to solve problems because of that design, the key value pair. So to challenge yourself, I would suggest that you have a dictionary of dictionaries. Play with that. Try to create a dictionary of dictionaries. And if you're able to create a dictionary of dictionaries, don't hard code it. Just start out with that. If you're able to create a dictionary of dictionaries and process it by walking through with for statements and printing the key and the values of that dictionary of dictionaries, I'm going to say that you're well on your way to working with data processing in an advanced way. So let's get into what sets are. Okay, so I'm not going to get too detailed on sets, guys, but here's the basic idea of a set. It is a special kind of dictionary. Because remember I was talking about how hash table is, a dictionary is a hash table. Well, a set is a dictionary where the key and the value are the same. What? Well, that's the whole power of a hash table. So let's go back to the whiteboard here real quick. And one of the solutions, before we had Google break out with and use binary trees for web spiders and search mechanisms, we had a big problem with sequences of data, because if we wanted to find data, such as we had a list of websites that we needed to search through, we would always have to take that list of websites, put it into an array or a list, and we would sequentially have to start at the very beginning to look for a specific keyword in that website. So let's say we put that website here, but the website that we have that value that we're looking for is stored all the way over here. We would actually have to start here and then look at each item to find that keyword for that website in a search mechanism. And before Google, I would Alta Vista was one of the and I use this a lot. And so if you've taken my courses before, you probably heard this little rant. But I would, before Google's technology using binary trees to reduce search times, I would put a search in for a specific web page. And because it was stuck with this mechanism, and some of the websites used fairly, hash tables as well, it was extremely slow. So I would put in my search term, and I would literally go get a cup of coffee, stand around for a little bit, go back to the computer, and the search is still running. It's still going through and trying to find that keyword in a specific website. When binary trees came out, that changed everything, because a binary tree actually makes it faster. And I would put it in the search term, and I wouldn't even blink, and the search items were up. That's how big of a difference in technology that changed. It changed everything overnight, and you guys are seeing that with artificial intelligence now. That same type of technology change. Before binary trees came out, we had to make things faster to find. We had hash tables. That's what we did, is we built hash tables. So the idea of a set is, let's say that I want to put the values Ford, Toyota, Toy, and Tundra, and I wanted to store these. Well, instead of having a key value mechanism, what a set does is it says, well, heck with that. Why don't we make the value of what we're storing also the key? Now think about that. Because if we are doing our mathematical mumble jumble on the value to determine where it goes in the list, then if we need to find something and all of its related data within a sequence of data, we can just use the value of what we're looking for to find where it's at. And anything else associated with that value could be stored at that location. So the mathematical mumbo jumbo would be done on Ford, and let's say that Ford evaluates to go at location 2. So we would put Ford right here. And Toy, let's say it evaluates to go to location 0. And then Tundra, let's say that it goes to the last one, which is 0, 1, 2, 3, location 3. So now what we could do is we could ask somebody for what they're looking for, reverse it, and do the mathematical count up, or however the hash table is designed, and determine that Tundra evaluates as 3, and then we can go to location 3 and get all the associated data with that particular value. So that's kind of how a set works. Is it's a hash table in its truest sense, being that the value that you're storing is used to determine where it goes in the list or the array. And that's why sets are not able to deal with duplicate values. Because obviously, if you're putting in Ford, and Ford will always evaluate to here, and you put another duplicate value Ford in, it's always going to go to the same place. So we don't want to add duplicate values. They just won't work, just because of the nature of how a set is. Now, usually what we use a set for is data that we don't want duplicated. So let's say that we want to convert a dictionary to a set to remove duplicate data. That can be done. Also, sets are used for mathematical processing. A lot of that, does set use a hash table? Yes, it uses a hash table. And then when we think about sets and how they work, well, they're soft-coded, or just like a dictionary is. So to create a set, you would do the same mechanism. This could be a set as well. However, it's not until we use this line that it actually becomes a dictionary and it differentiates from a set. Now, we could turn this into a set by using a different way of initializing the values inside of that particular collection of data. So I'm going to use collection as a word now to refer to arrays, lists, to refer to lists, dictionaries, and sets. Tuples, which is just an unmodifiable list. So a collection is a collection of data, and that data will behave in different ways based on how it's implemented. So when we're implementing a set, it only has values that are also its key, but you can't really kind of use it that way. So let's look at how we use sets. Well, strike that. Let's look at how we use sets in Python, because they control its behavior and how it actually works with. So you can start out a set just like you do a dictionary, but you see the difference here. This is how a set is created. You notice that there is no key value to it. So if I were to assign something inside of the set, and I soft code it, let's do, I believe we should have a function called append or add. But here's one thing I wanted to point out. You notice how the set can also do mixed data types. It can handle for an integral value, 34. It can handle for a Boolean, true. And it can handle for a string, all in one set. So a set can be mixed data types as well. And here's what you can do is when you're parsing a set, you can use the type to determine what type that data is and how you should process that data that's in the set. Okay, so this is some very, here is collection types, list, tuple, set, dictionary. Let's go in a little bit more into detail on set. You can, use the set function with arguments and let's actually look at that. Here is where we're declaring a set. Here we are creating a set in this manner, but here is where we're declaring a set using the set constructor. And that's how you can you can differentiate it purposefully from a dictionary by using the set constructor, which is just a function that tells that this variable is a set of these items. Okay, and now let's get into the functions that you can use for a set. The add method will add items to the set, and let's go ahead and do a quick demo of that. I'm gonna go ahead and before we get into a demo of these items, I'm gonna go ahead and come in. What we'll do is we'll do an add and an update. And I'll be right back. I'll come back soon, and we'll finish up. All right, guys. See you soon. All right, I'm back. Let's go play with some sets real quick, and let's talk about how it's differentiated between a dictionary, how that's actually done when you don't hard code it. So we see here this example. We're creating a set called set1. But you see that it uses the curly braces. I'll call these braces just the same as a dictionary. So how is that different? Well, dictionaries use the colon in there, of course. But how would I code a set without hard coding it? So let's go in and play with that a little bit. So this is our example that I use. And what we're going to do is we're going to differentiate this from an actual dictionary. And first by calling it a data underscore set. Now, this would make it a dictionary. So that's not possible. We can't, Python would get confused. So that's why we have that set function, the set constructor. And this is where we can actually make it a set and we will be able to apply it as an empty set at the beginning, and then we can use some of those functions that we have in our PowerPoint to fill up the set. So instead of doing this and hard coding, you know, stuff in here that would make it a set of items, you know, I'm going to assign it equal to a set, and it's going to be an empty set. So let's just see if that works. Let's do this data set. And you know, let's do this data set of, no, I don't think that's going to work. We'll get into that in a little bit. It's been a little bit. So we'll get it. We'll just get started on creating this set. So then let's do this. Print data underscore set. All right. So let's see how this behaves when we put it in here. Okay. Oh, okay. So basically it prints nothing. Okay, let's then put stuff in here, and let's look at our example. Not that example, your actual W3 schools. Okay, so it looks like we have to put a, you know, initialize it that way, but let's actually use the add function here. Now let's go back to our PowerPoint. And some of the ways of working with a set are the add method, and you can even update a specific item in the set. So let's go ahead and play with the add, and we will then use a for loop to actually break through and print the set. I think what we'll do is we'll demonstrate the union first, and then go from there. All right. Let's go back to our code. Data underscore set dot add. And we're going to add the value 1. Data underscore set dot add. And we're going to mix data types here. Let's just do something generic. Okay, now we'll print the data set and see how this behaves. And we can see down here that I hit play, and it's got the output 1 and then POW. So it's already behaving like a key value pair. So then, how do we run through it with the for loop? Well, the for each means that for every item K in the set, we're not going to use any subscripts for this example. We're going to say print the value at location, or print K, essentially. I'm doing that wrong. Print K, because K is going to be assigned first to the value 1. Then K will be assigned to the value POW. And then, of course, I can print the whole data set as a whole, or I can do it in pieces with the for statement. So let's go ahead and run this. This time I'm actually going to run the debugger. All right, and I add to the set, use a for each. K is first POW, then K is 1. So it adds in the order of last in, first out with your set. So we see that POW printed first and then 1 printed next. So last in, first out is a LIFO mechanism. And that's usually the way a hash table does things, is last in, first out. On. So we work with a set by using for item in set, the for each statement. Now we have union methods where we can add one set onto another set. And let's go ahead and look at how that works. Okay, let's do data set Oh, wait. Okay, we soft code adding to the data set. Now what we're going to do is we are going to... why is this tab not working? Okay, I'm now upset with this. Why are you doing this? This is why sometimes the extensions you can add, I don't particularly... oh, because I'm still in debug mode. I don't particularly like them because, one, they get in your way with that silly pop-up. But, okay. We need to use the 4K in set way of doing things. Okay. And then we can print K. All right, let's hard code another set. Data set 2 equals set, and let's do John with the value 1 inside of it. Okay, and I'm going to set the debug just so we can examine that, the memory, the local data set 2. We see data set 2, and it's filled with John and number 1. Okay, and then we print through everything in the set. But why can't we do a union? And we can say, let's create a new set. Let's overwrite the data set. Take the current data set value, all the items on that data set, and make it a union, unite it with the other set. And then what's the other set? Data set 2. All right, now let's go ahead and run that. Okay, so data set. And now we look at data set, and you see that it put those together. But here's the interesting thing. Look at the behavior of what happened there. So the first time I created data set, I added the value 1 and then the value POW. Then I took data set 2 and I added the value John and the value number 1. So you see, when I perform a union, I am adding John 1 to 1 POW. But each one has a duplicate value. So you see, when it made that union, it didn't add a number 1 in there. And that's where solving problems by design, that's where a set stands out. And one of the main reasons why you would use a set compared to other collection types. Your tuple, your list, which is a tuple, and then your dictionary. So that's one of the key mechanisms that makes a set useful. And of course, it's also good for doing mathematics on. So a lot of data scientists, or just scientists in general, will use sets. Okay, I think that's enough time on sets. I didn't want to get too far into the weeds on it. So you guys go ahead and look into a little bit more on sets and some of these, because what I wanted to get into, which is where you're going to be getting more of your assignment on, is I'm not going to choose an assignment where you need to use a set. I'm going to choose an assignment where you need to use a dictionary. I could be lying and change that, but for predominantly either or, it doesn't matter. I'm going to want you to be able to pickle a collection of some type. It can be any kind of collection. It can be in a list, a tuple, a set, or a dictionary. Any kind of collection of items, I'm going to want you to be able to write to disk as binary. Now, what happens is this is called serialization. And serialization, the reason why we call it serialization is because it's capable of writing data types as binary, and it's capable of handling string data types, because a string data type is kind of tricky to write as binary. When you write a string data type as binary, the issue is a string size can increase and decrease. Versus if you're writing an integer as binary, it's outputting the whole integer and all the 4 bytes that represent that integer. So essentially it's outputting the whole variable, and any value that's stored inside of it is part of outputting that whole variable. So serializing is really meant to handle mixed data collections, because and it serializes it and outputs it as binary, so that it can handle different data types and the different sizes of those data types. And it really makes it fairly simple to save your collections as binary. And serialization is another discussed in other programming languages, because it gets you beyond that string problem when you're saving files as binary. So essentially, it's all done for you. And that's the beauty of it. So we can create a set and then just dump the data of an object. So what it does is pickle will output a whole object. And since every data set, dictionary, and all those collection types are an object, you can just use the whole object to dump, instead of having to save every item that's inside of the object by hand, piece by piece. So you can create some collection of data and dump all the data out to file as binary with one line of code. It's beautiful. It's wonderful. It just does it for you. And then you can unpickle it and deserialize it back into its original form as a collection. And so it really makes saving collections of data fairly simple. So you use the dump function of the object, and then the file pointer of where it's going to be saved. And then you use the load, and you load the data back into that collection, a collection identifier, and the data will load based on what type of set it is. I'm using the term set and collection interchangeably here. Excuse me, what kind of collection it is. So mostly what we're going to be doing is working with dictionaries. So I'm going to give you an example of pickling a dictionary. And I'm going to use Google to find some of these code snippets and paste and copy them in. We're going to use our try catch. You know what? I think we'll just go back to some of the code that we created previously to get the file pointer set up. And then we will use the pickle code and the pickle module. But here's the thing, is that pickle code is part of a library. So what we have to do is we have to import that pickle library before we can use that keyword pickle. So let's go ahead and set up our file reading first. And we're going to create an empty data set, or an empty, I'm going to go ahead and hard code a dictionary. If I use data set interchangeably, I might use data set, I mean the dictionary, even though a set is something totally different. So let's just hard code a dictionary in here, and let's do mixed data types. Let's go ahead and just hard code it, put it in the file opening code, and then we're going to dump it to the file, modify the code, and then read it from the file. So let's go ahead and do brand. Let's do Ford. And then let's do... this needs to be a colon because we're doing dictionary, not a set. Then we do a comma for the next key value pair. Let's do power, pow, and then let's have 300 in there. So we'll just do a mixed dictionary, and I put that in there wrong. That needs to be a colon. Okay, so now what we need to do is we need to import the pickle. So we import pickle, and that gives us the ability to use that pickle keyword. Now let's go ahead and look at some of that previous code that we built that opens a file. I'm going to go to the desktop. I think I can't remember. I think we did chapter 3 or some kind of thing. It might have been something else. Module 3? Yep, read text. There it is. Okay. So instead of a text file, we're going to use a binary file. So what I'm going to do is, let's zoom out a little bit so I can see this whole thing. I'm going to grab the whole try except block, and we're going to grab things out and put things in. But we're going to use a .dat extension for this. We should not be using .txt extension for binary files. So let's go ahead and put that in there. And yeah, I'm going to do Control Z because I'm kind of a little bit upset that my paste didn't work with the indenting. There we go. My paste worked because I backed up to here with the cursor and then pasted it in. And it looks like we don't have any indenting issues to deal with here. So let's just modify the code then. The file that I'm going to call is going to be called data.dat. Okay, and then if you ever, are wondering what directory your file is your file is being put in, you can always do the read operation or the write operation. And I'm going to change this to a writable opening of the file. So I'm opening it in W mode. I'm using the .dat extension instead of text because this isn't a text file. Then I'm going to write the data. Okay, and we're going to examine the file afterwards and see what we get, what it looks like. Okay, so this is where I open for dumping. I'm not going to use the write function. I'm going to open it up in the pickle mode, and I'm going to use the pickle code to dump the information out using the file pointer FID. So when I go back, let's go back to the PowerPoints, and the PowerPoints say that you are going to use the dump function, but you need to dump it to a file pointer. So you're going to dump a whole object out with everything inside of it and to a file pointer. So you just need to open up a file with that file pointer, and then you can use the pickle dump function. Okay, and it looks like, let me get rid of some of that white space. But the thing is what object am I dumping? Well, it's the dataset object. So I'm going to rename that dataset. And then what file am I dumping? Well, the FID file pointer, or file object, as your book would use. So I'm going to put FID in there. And then here's what's important. Immediately close it, guys. Whenever you're doing file operations, unless you're doing random access, and even if you're doing random access, I would open up the file, do my modifications, and close the file as soon as possible. You should never have a file opening where you're allowing the user to do menu options to change that file, because what happens is if your program, if it dies, it keeps that file open and it never closes it and basically ruins the file. And there's a lot of different applications out there that can go in and close the file for you and put that file close special character set or binary value. No, it's not binary. It's a character, end of file, EOF character, and close out the file for you. But it'll still just ruin the file. So make sure you close it, get in, do what you need to do, and get out. All right, so let's do this. We are not going to do anything here we are going to get rid of all this stuff, and we want to just open the file, dump it, dump the data set, and then let's examine what is actually output. So what's going to happen is, since I told this to go nowhere, essentially just output to data.dat, it's going to output that file in the working directory of my script. The interpreter is going to do that. So let's go ahead and just run the debug, run and debug. I'm going to step over. Boom, open the file. Good, we're good. Dump, no errors. Oh, uh-oh, what happened there? Uh-oh. Oh, I sent the file pointer. You know what? That may be an issue because that's supposed to be a string. Let's look at some. Pickle dump examples. I may have misinterpreted that and forgotten the actual syntax and semantics. So let's do this. W3 schools pickle dump. And this is typical, guys. You know, references are always nice to have around. So let's look at an actual pickle example. It looks like, right binary. Oh, there we go. That's where we messed up. I think right there. Because it looks like from this example, let me zoom in on it for you. We are creating a collection of data. In this case, it looks like a list. We're appending data. We are opening the file, but look at here, WB. Because when we pickle, we're not doing a write text. We need to open it with write binary. And then, of course, we're going to give it a name. And then we give it the data object and then the file. So let's go and modify and see what we did wrong there. Pretty sure that that is the issue. Okay, hit stop. Okay, let's go here. WB. We give it the name of the file. Then we close it after we do our dump. Send it the file pointer and the objects we want to output. Let's see if we have any issues. Okay, step over, step over. Good. Okay. It didn't die on me because, you know, if you want to rewind back, but that's exactly where the exception error was thrown, because we tried to dump that data to a file that we opened up in text output mode. We put just the W here when we need to put write binary and open it up the file in binary mode. Not only binary mode, but write binary mode. If you need to read the file, you're going to open it up in read binary mode. Okay, does it close the file well? Yes. And it prints the data point. Good, yes, it works. It's good. All right, now let's go look at our folder. Our folder, if I remember right, is desktop. What was it? It was it chapter 4? No. I got so many folders of different things in here. Oh my goodness. This is a nightmare. Which one was it? Did I actually put it in chapter 6 golf? No. It was something else. Oh, here. I could just look up here. Look at that. I'm being silly. It's right here, isn't it? Okay, it's in module 4. All right, let's look at module 4. That's another way that you can know. No? What the heck? This is desktop. Oh, that's chapter 4. Oh my goodness. Module 4. Okay, that's going to be in the M's, isn't it? It should be in the M's. Let's see. Name. Okay. Oh. Module 4. Oh my goodness. Oh, there's our DAT file. Okay, now what you would want to do is, often you don't have your text editor set to open up a DAT file. So you can right click on it and say open with Notepad. And you can see that you see all these weird characters in here. That's just Notepad's representation of the binary that's input. But here's the thing: is you see it outputs Ford in clear text. That's Pickle's dealing with how it does a string as binary. So almost all strings that you output as binary when it does serialization, no matter what programming language you're working with, Java, whatever, doesn't matter. It's going to do the binary output in its native string represented form, and then everything else is going to be the whole variable itself, outputted, like an integer. All 4 bytes that represents that integer in RAM is going to be output to disk, and you can actually use the disk like it's random access memory because it's outputting the whole integer, not just what's inside the integer. And that's the difference between text and binary. So you don't want to output, you don't want to have the .txt extension for binary output when you're doing binary output. And Pickle is binary. It's serialization, all serialization, whether you do serialization in a Java or any other language, it all works pretty much the same and is implemented in the same manner. So let's do this. Let's test to see that we are actually doing this correctly. And let's create an empty data set. Okay. And then let's open up, but this is where we're going to change things. This is where we're going to do read binary. We know that we got the location right because we just outputted it. But instead of dump, we're going to be doing something else. Let's look at our PowerPoint. Load. And we just need to do load from file, and what it returns is the object that it deserializes. So let's go ahead and look at that example. And instead of dump, I'm going to say load, and the only thing it really needs to do is you only need to send it the file pointer because it just needs to know what file object it's loading. And then of course when it loads it, it needs to store what it loads somewhere. So we're going to assign our data set equal to loading what Pickle deserializes for us. And essentially what we're doing is we're outputting the whole object as one big chunk as binary. And guys, this is how your games do things. So when you ever save a game, what it does is every object in your game that's been created, character object, anything about the character that's inside that object, like a weapons object, any object, what it does is it saves it out to disk as binary, and that way when you load your game in, it has every object has the same data in it when it loads it back in. So your character has the same data when it deserializes it from disk. And so that's how writing output as binary when you're using serialization works. Otherwise, you would do a random access file, and you'd have to do it by hand and handle for the string problem because strings can increase and decrease in size when an integer is always 4 bytes and a double is always 8 bytes. And of course Python doesn't care. It is able to go between data types seamlessly without you having to, in most parts, actually do the conversion. Sometimes you have to, manually convert an integer to a string using the str method with parentheses and whatnot. So let's load it in. Let's close the file, and then what we print should be what we saved to disk. So let's go ahead and run this. And we got our data set. Boom, it's empty. We open the file. We load the data. And we can look over here. Did it load the data? Yes, it did. Beautiful. It's working. Then we print the data set after, and notice how I close the file. Immediately, as soon as I go from the disk and I put it into the RAM, I close that file. Now I can use that RAM that I loaded from disk so that I can have persistent objects. And this is what I call object persistence. And that's, again, how your games save and load from disk when you save your game. It's with object persistence. And it usually mostly works with some kind of serialization scheme. And serialization just essentially outputs every single item, every single primitive data type that's inside of a specific object serially. All right, I think that's enough. We've gone in probably a little bit over than I wanted to, but we've got some good examples and demonstrations. The next video will be something that takes one, an actual problem and demonstrates how to begin solving that. All right, guys. Goodbye. Thanks.